Hey everyone, welcome to another video in our series on the atomic model. So if you recall, in our last video we talked about our current atomic model, but one thing I would like to point out is that usually science is not easy. We don't get there in the first step. It takes a lot of time, dedication, and willingness to change our theories. So originally, our model of the atom was very different from what it is today. And it was the willingness to be able to gain new evidence, gather new evidence, and change these models that really got us to our advancements in science today. So what I want to do is recognize some of those earlier historical models that had a profound impact in determining the structure of today's atom. And indeed, determining the structure of an atom also enabled us to understand many other properties like how compounds form, how electrons work, how ions work, isotopes work, all of that neat stuff that is a result of atomic chemistry. So let's begin with the original model of the atom, which is called Dalton's atomic theory. And Dalton came up with the idea of an atom in response to a question posed by Democritus almost 2,400 years ago. He was a Greek philosopher, and he asked, if I keep on cutting a slice of cheese in half forever, will I ever stop, or will I end up with something that I cannot cut anymore? So Democritus hypothesized that he would end up with something too small to cut. He called it atomos, which is the Greek word for indivisible. And Dalton decided he's going to explore a little bit more about this idea of atomos. John Dalton in the 19th century, so this was almost much later than Democritus. He was one of the first scientists to discretely describe atoms. So Democritus did not discretely describe these atoms, but Dalton did. And we call his theory Dalton's atomic theory. And it has the following 5 crucial statements that, in his opinion, define atoms, or given the information at that time in 1804. He thought that all matter was composed of tiny, definite particles called atoms. He thought that atoms were indivisible and indestructible. All atoms of a particular element shared identical properties, including weight. Atoms of different elements contain different mass, and atoms of different elements combine in fixed whole number ratios when forming compounds. Now, as it turns out, some of these statements are not actually true, as we would likely expect for the first atomic theory to ever be proposed, but it is still quite impressive how Dalton was able to conclude some of these statements. In fact, some of them still hold today for a majority of cases. For example, all matter is composed of tiny definite particles called atoms. That holds true. Atoms are indivisible and indestructible. It turns out we can actually divide atoms a little bit more into ideas called quarks, which are fundamental particles that we can split neutrons, protons, and electrons up into. But that's a discussion for another day. All in all, given the information, he thought that atoms are indivisible, but actually as more advanced science and technology came along, we realized that we actually can divide the atoms. But this is still quite impressive. All atoms of a particular element share identical properties, including weight. Well, due to the fact that isotopes exist, we also know that this is not entirely true. Atoms of different elements contain different masses. Once again, due to isotopes, this is not entirely true. For example, you can have carbon-14 and nitrogen-14, different elements but almost equal masses. And finally, atoms of different elements combine in fixed whole number ratios when forming compounds. This is remarkably true. This was actually an observation he made while investigating investigating compounds involving oxygen. He realized that the ratios of atoms is always in a fixed whole number ratio. So for example, you can't have H2.50. It's H2O. You will never see decimals in the molecular formulas of compounds. And the reason is because of this statement. So Dalton's law, to summarize, was quite impressive almost 200 years ago, in the sense that given the information then, the conclusions he drew were spectacular and ended up pushing forward the atomic theory for the future. Our atoms are based off of Dalton's, and only Dalton's model was able to be improved and grown and developed on. So he served as a starting point for us to continue. And you can clearly see the difference between his atom and our atom for today. He thought that an atom was just a big, nice bowling ball, like a solid sphere, and it didn't really have any other interesting properties. It just made compounds. Of course, now we know today that atoms are a whole lot more than just big solid spheres, and rather entities that are quite a species on their own. In the next video, we're going to investigate how we got even further and developed on Dalton's atomic theory to take us to J.J. Thomson's plum pudding model of the atom. See you there.